Have you ever wondered where your next move would take you? We've all had a what's next moment. Maybe it was what happens after high school, or what comes after college. I remember sitting on the floor of my dorm room, flipping through a course catalog, when I learned structural engineers can design amusement rides. How cool is that? I was instantly inspired and chose my major because I wanted to design something for Walt Disney World one day. After college, I began my dream job, working at Simpson Gumpertz and Hager, the engineering firm known for designing Spaceship Earth at Epcot Center. You know, that giant silver golf ball. But sadly, my first large project had nothing to do with Disney. Instead, it was a nuclear facility. Now, the word nuclear tends to spark two very different reactions: risk or possibility. At the time, I had a lot to learn, and I began to wrestle with a question I think a lot of us face at some point. What happens when the thing you thought you wanted isn't the thing you end up doing? Because I didn't just want to design structures, I wanted to know they mattered and would impact people's lives for the better. Slowly, that's what nuclear began to represent. I learned that nuclear energy provides nearly half of America's carbon-free electricity, equivalent of taking more than 100 million cars off the road every year. This reduces air pollution that would otherwise contribute to challenges like stroke, heart disease, and respiratory diseases. And then I began to understand its reliability. While an excellent part of the clean energy mix, solar doesn't generate at night, and wind, it depends on the weather. But nuclear, it's there, reliable, a source of baseload power. And its efficiency. I learned that just one uranium pellet, the size of a gummy bear, produces the same amount of energy as 1 ton of coal, 149 gallons of oil, and 17,000 cubic feet of natural gas. And of course, I had questions about the waste. But I learned that all the nuclear waste produced in the United States over the past 60 years could fit inside a football field at a depth of 30 feet. And research to recycle that nuclear waste is underway. And just as I was beginning to see that side of the industry, everything changed. You may not remember, but in 2011, a massive earthquake struck off the coast of Japan, triggering a tsunami that overwhelmed the Fukushima Daiichi nuclear power plant. I remember watching the news, seeing the images, and thinking, is this what I've gotten myself into? Because this wasn't theoretical anymore. This was failure in the real world with real consequences. But it's what happened in the aftermath that surprised me. The nuclear industry didn't disappear. It didn't avoid the issue. It responded. Engineers, regulators, companies, they came together to ask a hard question. What would it take to reduce the risk of this ever happening again? And I got to be a small part of that answer. Our team had the opportunity to design a structural retrofit for a backup water tank at Pilgrim Nuclear Power Station, something that could provide cooling to the reactor core, even in an extreme scenario. I got to visit a new National Response Center where backup equipment is stored, ready to be flown anywhere in the country at a moment's notice. And for the first time, I began to understand what it meant not just to design for ordinary conditions, but for the unimaginable. Now, in nuclear structural engineering, we don't just design for typical loads. We design for earthquakes strong enough to shift the ground beneath the building, for tornadoes powerful enough to turn cars into missiles, for situations where structures don't just stand alone, but they interact with the soil and each other in ways you can't even see. And it all comes back to this one idea: what happens on the worst day? That question changed how I see my work, and it changed what I value. Now, recently, our team had the opportunity to work on a project called DOME at Idaho National Lab. This 1960s structure was being dismantled when a team asked us to design a retrofit so it could be used as the world's first microreactor testbed. Now, microreactors are small, much smaller than traditional nuclear plants. Just one could power 20,000 homes, but their potential is huge. They're designed with passive safety systems, meaning that if something goes wrong, they shut down automatically. And because of their size, they can be deployed in places traditional clean energy can't reach: remote communities, disaster zones, and potentially one day, space. But microreactors are just part of our energy future. The nuclear industry is at a turning point. We must maintain our current fleet of nuclear infrastructure while moving forward on the next generation of nuclear. With the rise of data centers, electric vehicles, and artificial intelligence, the demand for clean, reliable power is accelerating faster than ever. And here in the US, climate goals to reach carbon-free electricity by 2035 and net zero emissions by 2050 are fast approaching. And we can't meet those goals with wind and solar alone. With all of that being said, I began thinking about my original dream. Because the theme of Disney's Spaceship Earth at Epcot Center is that we're all traveling together on this shared planet. And we have a responsibility to care for it. And in a way, this work felt like that. Not designing a ride inside a sphere, but designing the homes for reactors that provide reliable, carbon-free baseload power for the world. Power for my kids to learn and grow. Power for doctors to care for their patients. Power that you and I depend on in our everyday lives. We each make decisions every day about the paths we choose and the possibilities they offer. And you each have a role to play in the future of energy, and what you consume, and what you support, and the steps you will take to see the next possibility. So I'll leave you with this: what will be your next move?